Dear students, good morning. So we are going to start our video lessons. So this is the first lesson on power power system, that is CAPSA. So in power system already we have covered few topics in class. So as this is a video lecture, so whatever portion is left I will be continuing in depth. So let us discuss or start with power unit system. In power unit system, what is the definition? First let us see the definition of power unit system. As you can see, so the power unit system means, in simple, it is known as PU. Okay, that is, it is the ratio of actual value by base value. Ratio of actual value by base value. This is a simple definition of PU system. So PU system is very important in power system analysis, because if you don't know PU, then it will be very difficult to deal with problems like in fault analysis and transformers. In transformers it helps a lot, mainly in transformer, because in transformer we have got two circuits. This is the primary and this is the secondary. So we have two circuits in the transformer. So if we consider a power unit system, we will have a same value in both ends, that is power unit in this end and power unit in the primary and power unit in the secondary will be same if we consider in transformer, because this will be secondary, this is secondary. Okay, so simple definition is of power unit system is actual value by base value. So please note down this one. Next we'll see suppose impedance, let us consider Z per unit. So actual value Z actual by Z base. So base value I will be writing like this, ZB. So let me erase this one. So see, so impedance means what? Base, impedance base means voltage base by current base. Voltage base by current, V by I is equal to Z. So what you can write? Voltage rated into voltage rated current rated. Okay, so what I did is that ZB equal to VB by IB equal to V rated by I rated, voltage by current. So both side I have multiplied by V rated. Alright, so what I'll get? I'll get, you see, V rated square divided by V into I. V into I means V, volt ampere. Okay, so finally what I got, this is the base value, this part is the base value. So base value I got ZB equal to V rated square by VA, and what we know as power unit equal to actual by base. So actual will remain, actual means Z in terms of ohm divided by this. If I divide this, then what I'll get, V rated square into this VA will go in the numerator. So finally what I'll get this formula. Okay, V per unit equal to, that means the impedance. If you are asked to calculate the impedance Z per unit, that is Z in ohm by V rated square into VA. Now in terms of VA, suppose in terms of MVA, because in power system we then mainly deal with high voltage. So if we deal with high voltage, then obviously more voltage means high units we have to consider, like in terms of mega. So in terms of mega, so if I want to convert this to mega, what I have to do? I have to multiply both sides by this V. I have to convert to MVA, so multiply by 10 to the power 3. So here also so therefore final what I will get, Z per unit equal to Z ohm into MVA divided by kV square. So this is the main formula. You should remember this Z per unit, because every time we will be using this, and using this formula only we will be calculating only Z per unit value. One note point you have to consider like the note point is like very important note point, that NB, I have written here NB, that PU, that is per unit value, is defined, per unit value is defined on per phase only, on per phase only. Okay, so in single phase only we define PU value, not in three phase. Suppose we have a three phase line, then what we do is that three phase line means three single phase, so per phase we have to calculate. Okay, per phase we have to calculate the value. Alright, now this is to the per unit value in terms of single phase. Now suppose the type of connection, based on the type of connection, how do you represent the values? Let us study that. Okay, now see, for Y connection, this is star connection, what should be the value? If the connection is star, then Z per unit equal to Z in terms of ohm MVA divided by kV square. So for a three phase connection, the formula would be Z ohm into 3 phase MVA. I have already told you that we always calculate PU in terms of per unit, so divided by 3. So as we have a three phase connection and as it is a star connection, so you know line voltage equal to root 3 times of phase voltage, and we always calculate at phase. That means V phase equal to V line divided by root 3. So here kV line divided by root 3 whole square. So when the type of connection is star, what we get? We get Z per unit equal to Z ohm into 3 phase MVA divided by kV line whole square. Okay, this and this will get cancelled, so this is the final expression we get. Okay, Z per unit equal to Z ohm. That means in actual value into 3 phase MVA by kV L square. I hope it is clear. Now, if the type of connection is delta. Okay, if the type of connection is delta, for delta connection, let us see. Please forgive me for the handwriting. Okay, for delta it is Z per unit equal to, we have Z ohm into, formula is same. Okay, MVA by kV whole square. So Z ohm. So as we calculate for single phase, so what I did is that MVA divided by 3, and in delta connection line voltage is equal to phase voltage, isn't it? V line equal to V phase. So what I write here, kV will remain kV only, kV line whole square. So what finally I'll get, let me write, change the color of the font. So 1 by 3 Z ohm into MVA divided by KVL whole square, Z per unit if the type of connection is delta. Okay, so from the two type of connections, what actually we got, you see, we got that whatever be type of connection, your Z per unit is directly proportional to MVA. Okay, mega volt ampere, and inversely proportional to K voltage square. There is another important formula for Z per unit. Now say whatever we have calculated just now, all we have calculated from Z value. Okay, base value. Now suppose base value, that means those values are not given in per unit, those are given in powers, in voltage, in currents. Like suppose Z base. Okay, Z base is kV square by MVA, or if you know, suppose this is in terms of voltage and power. Okay, this is the base power and this is the base voltage. Now Z can be written as V equal to Zi. That means if you already know the base voltage and base current, you can easily calculate. This is another formula. Now the values are already given in per unit, then what would be the formula? Suppose the values are already given in formula, so this is very very important. Okay, Z per unit new, Z per unit new, suppose new value you need, okay, from the old value. So Z per unit old into MVA new divided by MVA old into kV old whole square divided by kV new whole square. So this is a very important formula of per unit system, because many times we will be using this formula. Okay, so try to remember this formula. Again I am repeating, you see, ZPU new, that means a system is given. Okay, in that system the values, that is the impedance, the power, the voltage, everything are given but in per unit. But you are asked to calculate new per unit value, then in that case only you will be using this, like Z per unit new equal to Z per unit old into MVA new by MVA old into KV old whole square by KV new whole square. Okay, now let us solve a very simple problem. Suppose given a 50 MVA 3.3 kV generator has a synchronous impedance of 10%. Find the per unit impedance on a base of 100 MVA and 5 kV. Okay, now our generator is given. So our generator is there. This generator rating is given. That is what? MVA rating. How much? 50 MVA generator is this. Is a 50 MVA generator. So 50 MVA generator, and voltage is given how much? 3.3 kV. Okay, its impedance, there is an impedance of that. So impedance Z is given as 10%. Okay, so find the per unit impedance on a base of 100 MVA and 5 MVA. Now you see, so old values are given and new values you have to calculate. Now how to calculate? Let us see. So I have just now given a formula, Z per unit equal to Z per unit old into MVA new by MVA old into KV square old divided by KV square new. Now say Z per unit old. Okay, old. That means the system per unit value. Now they are asking find the per unit impedance on a base. On some base you have to calculate. It means this new value you have to calculate, and this is the formula you know. Now what is Z per unit? Z per unit old they haven't mentioned, but you can easily calculate. From where? From the given data. We know what we know. Let's take a different color. So we know, you see, Z per unit, okay, is what? KV square by MVA. This is the old value, okay, old value of that. So KV square, how much? 3.3 kilovolt, okay, kilovolt square, 3.3, and MVA it is 50. So this is the old value. This is what? Old value. So old value, let me write here, 3.3 whole square by 50 into MVA new. MVA new is how much? Find the per unit impedance on a base of, so on this base you have to calculate. So you write the new value, that is 100 MVA in terms of MVA. So in terms of MVA it is given, so I have written 100 by MVA old. Old is how much? Which one is old? This is old. So 50, you write 50 into KV old. KV old means previous value. Previous value is how much? Previous value is KV old 3.3 whole square by KV new. KV new is how much? 5. And you see, one thing I have made a mistake here. So the ZU old is this synchronous impedance of this. Okay, I should have written here this, not that. Actually, yeah, this is Z per unit old. Z per unit old is this 10%. 10% means 0.1. Here I should write 0.1. This is the value. Now you calculate the value. The value you will get after calculation 0.1 into 100 into 3, 0.1 into 0.4356. you will get 0.4356. okay, so this is the answer. I hope the problem is clear to all. Let us take another problem, a very interesting and important problem. So let us consider a transformer. Let us consider a transformer. So suppose the type of connection is, any type of connection let it be, it doesn't matter. R01 is given. R0 is, that is in the primary side the resistance is given as 1 ohm. In the primary side the resistance is 1 ohm, and it is suppose a 1 kVA transformer, and number of turn is 200:400. Now see what you have to do. Let us consider the per unit value of this transformer in the primary side. Now R01 per unit, not 1 means in the primary side. So what is the formula? Actual value by base value. What is actual value? R in terms of ohm by base value. If you write, then the value comes out to be VA by VB square. It is VB square by VA, isn't it? Now what is the value given in the primary? It is actual value. Actual value is 1 ohm. And what is VA value? VA value is 1 kVA divided by how much? VA is 1 kVA, but in terms of VA we are writing, so it should be 1000. And what is the voltage in the primary? Voltage in the primary is 200. So that is 200 number of turns. So number of turns is directly proportional to voltage. So whatever is the number of turns, that would be the voltage, isn't it? So 200 square. So what you will get? We will get 1/40 PU. 1/40 PU we got. This is in the primary side, and in the secondary side you see, if you write resistance, okay, suppose I want to convert this resistance, shift this resistance from primary to secondary, I want to shift. So what is the formula? That is R02. What is the resistance in the primary? How much is the resistance? 1 ohm into, what is the ratio? 200/400, that is 1:2. So it should be what? 2 square. So resistance in the secondary is 4 ohm. Now let us calculate the per unit value in the secondary. So let us calculate the per unit value in the secondary. What will see? R01, R02. It should be R02 per unit. Okay, R02 per unit. Let me take a different color. So R ohm into volt ampere by VB square. What is the resistance in the secondary? 4 ohm into VA. VA is volt ampere. Volt ampere is how much? Volt ampere, it is 1 kVA only. Okay, because the power is same, because we know in a transformer primary and secondary power does not change. What changes? Voltage and current. Okay, and what is the voltage? Here voltage is 400 volts. If you simplify this, here you will get 140 per unit. That means what conclusion we can make? The conclusion that we can make that in a per unit system, okay, the separate circuit in a transformer does not become or does not act as a challenge, because in a per unit system, if you work, that is in the primary as well as secondary, we get the same value. So this is the importance of per unit system in case of a transformer. Alright students, I hope you have understood the video. If you have any doubt, you can comment. Okay, so I'll be coming with some other video. So let us stop now. Let me stop here. Thank you.